Hello guys, this is Sunil. So hope everyone is doing well in this pandemic period. I'm just creating this video just to be update everyone that what I have learned in this pandemic, because with office work we know that we do everyday office work, but something that has to be done on along your side. So to be more focused on your technologies. So as I told, the learning was not perspective of you want to learn something, earn something from this, because my guru always said that never try to learn to earn something, but earn from whatever you have learned, right? So with that, what I have learned in this pandemic basically. So I have learned one of the graphics technology, which is OpenGL, because in market there are multiple technologies which talks about this graphics like OpenGL. There is a Direct 3D, there is Apple Metal, there's a Vulkan, right? So if your real-time renderings happen, the online renderings. So from that, I have learned OpenGL. So and where all the games are basically developed, right? If you talk about every game in which you might have worked on it, right? Maybe you have played already, Cry or some other games are there, right? So for to development of those games, it uses this following technology that I have just now mentioned, and so from that I had learned OpenGL. So talking about the OpenGL, so it basically utilize the your graphics card, because everybody, that when you are playing the games you need a proper graphics card, because that will help you to run your games faster than running on the CPU, right? CPU can't be able to do those heavy image processing and playing of the video with a proper FPS speeds with the CPUs, or with the CPUs, right? So we need that graphics card. So OpenGL is one technology where this all the rendering happens, right, with the help of the graphics card. So along with that, the the way open graphics card nowadays utilizing it, right? So uh, OpenGL graphics card are mostly focused on, initially it was focused on only on the rendering something, but nowadays the meaning of the graphics card, I mean the utilization of the graphics card is like, uh, since they are more capable to doing some operations in a parallelism, right? So they have provided some kind of interfaces. I mean, there are some companies which, like, if you talk about the NVIDIA or some other companies which produce this graphics card, they are coming with some technology which will, uh, they are giving some platforms and API which will be used to use your graphics card not only for graphics processing, but using it for the general purpose processing. So if I talk about, let's say, I want to do some calculation. Let's take example of, there are two arrays with let's say 1 crore elements. I want to add to this array element, each every one elements, and save that output in the third array, right? So what you are doing is the operation is same, the adding of the two elements, but we are doing it on a separate elements, right? Now if I ask CPU to do this operation, right? So there are 1 crore elements. So how much what is the in which max period of time this will operation will be executed, right? How fast this will be executed, basically it depends on your how many cores you have, right? But if I talk about the core, right? So how many cores do I have max in the CPU? So currently my machine has so again one of the latest processor I can see here, as I have I7 9th generation, right? So which has around no about 6 cores, but what max we can go, maybe a 16 core, maybe 32 core, okay fine, but what next? I mean, we need to spend more money on this, right? So rather than doing that, I do have a GPU which has a capability of providing a lot of cores. Obviously they are not similar to CPU cores, they are like horses which will be able to do some basic calculations of fastest, because they have a lot of cores than the CPU cores that we have, right? So NVIDIA, NVIDIA company, right? So they have provided one of the platform which is a CUDA platform, right? Which will talk about the heterogeneous parallel programming. So what this HPP stands for, basically it's doing the parallel work, computing basically, not with the help of two CPUs, because when two CPUs are working, I'll say it's a homogeneous, but when CPU and GPU are working together, I'll say it's a heterogeneous. So it's a, when doing the parallel work with the help of CPU and GPU, so that's how it's a heterogeneous parallel computing. So if you talk about the nowadays latest trend, right? So you have ML, we have big data, you have whatever latest you talk about, latest technology, more mini core computing, massive parallelism, all of this always comes to the under the hood this core native programming language. I mean the core native platform, which is the CUDA platform. I mean the CUDA is I'm talking about NVIDIA, but some other cards have some other OpenCL platforms where they can utilize this to have massive parallelism, right? So so all of them, big data and everything, they're all upper level, I'll say higher level technology which utilizes this underlying core platforms. And what we had done the OpenGL, it's again it's a core code programming, core code only. I mean it's native programming, not this C, it's not a Java, it's not a C sharp, right? Or it's not even Python and the web programming. It's a native programming that we have used here, because we need to talk with the drivers. So driver API using directly here in order to run our C codes on the kernels of the GPUs, right? So with that, so what I'm going to demonstrate, I'm going to give you a demonstrate application where the sine wave example, where I'll be going to render some sine waves, but to generate the sine waves we need some points to be calculated, right? So that point calculation will be done on CPU as well as the GPU, and I'll be giving the brief comparison between this, how this works on the GPU and CPU, and you'll see the magic that, right? And already have a powerful CPU as well here, but let's see what magic is, right? So before starting the video, I mean I just give the walkthrough of my code where at the high level this is a Win32 STK code I can see, and I'm using the OpenGL here for the programming pipeline concept here, right? And what I'm going to do here, I have code where the calculations are happening on some of the calculations happening on CPU, and some of the calculations are happening on my GPU, right? So if I just give the example, so on the CPU I'm doing this calculation, some array calculations here there, and I also have one more file which will basically do the calculation on the CUDA kernel on the GPU side, right? But I'm launching this. It's the same calculation. It is just that I'm doing on the CUDA side and not the CPU. It's happening on GPU. This is happening on a CPU. And how many calculations will be there at the initial state? I'm generating the number of points as 128 into 128 into 4, so that means around 65 points will be generated initially, right? And I'll be going to increase that points eventually, and then decrease, and see the comparison, right? So I'll first compile my CUDA file where I written the kernel code, and then I'll compile actual original file, CPP file. I'll link with CUDA as well as the original CPP file. You can see here I'm linking this with the CUDA computing framework from the NVIDIA. And now I'm going to run my applications. Okay. Oh, sorry. I think. Okay, fine. You can see here at the moment this is running with the 65,000 points, so sine waves, and it is running at the moment on the CPU, right? So what I'm going to do, I'll just make it as full screen. Maybe I can just change the colors here, right? Maybe a blue or maybe a red. Okay, make it as a green only. I'm going to increase some load here. I'll say to CPU that okay, don't create a 128, but I'm going to increase it 256 into 256 into 4. So I'm going to increase this limit now, right? So I have going to let's discuss, going to increase, this is increased, now it will become the 2 lakh elements. Now again I will going to increase some load on the CPU to generate more points, so I'll just increasing double. Now it becomes around 11 lakh elements, which is right now at the moment is generated. I am asking one more time to increase this load. I'm taking as a 1024 into 1024 into 4, so that means around 42 lakh vertices will be rendered. You can see the CPU is now at the moment where he's not, I mean in the stage where he's not rendering properly. That means he's on heavy processing mode and he's not able to give that back performance to me. Okay, let me do one thing, let me increase one more time. This time it's like 204 into 2040, that means it's around 1 crore 65 lakh elements total points are generated, and CPU is completely stopped. CPU is not at all responding, right? Now see, you'll see the magic. I'll ask my application to switch to the GPU and run the same calculation on the GPU. See the magic, this is running on the CPU. So there are elements which are 1 crore 68 lakh elements there, but you can see the smoothness on the GPU, right? It's like when you can't see any lag here. It's because it's running on the GPU, and there are n number of cores on the GPU which is utilizing, right? So that's the difference. If I again switch back to the CPU, you can see the difference. It's hanged. But if I switch to again GPU, that's the magic, right? I'll be decreasing these vertices now, right? Maybe I can just make this size more, decrease it, so it's now back to the original state, right? So with that, I think you must have got this idea of what this GPU is doing, right? What is the capacity of this GPU. So at the moment, I'll say on the GPU side, we are using I have a GTX 1660 card which has around 1500 cores, which cores are basically utilized to generate those points. And what CPU may I have 6 cores, right? So it's like GPU has a horses which run these codes parallelly on their cores, because those are like a horses and which run faster, because we have multiple cores. The same data is there, it is just that the running on the different cores, right? So that's a CUDA kernel that providing to you more massive parallelism. And when you talk about the big data or everything, right? So these are all upward technology. They are utilizing these frameworks. You talk about the Amazon clusters, Amazon instances, right? They are utilizing this multi-grid GPU system where they are combining multiple GPUs to perform some heavy processings, right? You talk about the TensorFlow library, which again the abstraction which is written on the top of this framework. Talk about the MRI reports, they're also utilizing this framework. So all the heavy processing that you see in the current market, all of them are utilizing this native platform to have parallel massive processings. So that's the beauty of it. So as a programmer, you should basically, if you have graphics card, not to be used only for your game programming, but utilize them for if such kind of works where we have parallelism can be achieved with maximum parallelism, right? So so that's something which I learned. Again, everything that I have learned with my learned from my great guru, Dr. Vijay Dattatray Gokhale. So you can, there are no words to explain what this person is and out of. So you can take more help of this website, Astromedicomp, where you can know about this person, who is and what they actually do. I don't have words to explain, right? So you can check on this site about the Gokhale sir, right? So we have everything that I have learned is from the Gokhale sir only. So just explore and see the magics and do the magics. So that's it. Thank you guys.